Hello, hello. So I think I'm live. So today we're going to read a new paper. In fact, it's an old paper. So the paper is Activation Functions in Deep Learning, a Comprehensive Survey Benchmark. Nothing, no, nothing special. Just a, comprehensive survey of activation functions. So my plan is, just 1 second. Special. Okay, all right, all good. So my plan is to also read another paper, like the introduction of ReLU. Yeah, this one. Though this is a 2019 paper. Did ReLU come in 2019? I mean, at least as activation functions in mainstream, at least. I don't think so, but I may be wrong. And this paper was released in the year 20. Oh, it's a recent paper. It's at least 2021, right? 2020? Yeah, I guess so. So this is a pretty new paper. So I think we will read this. So I think since the paper it's a like survey, it's probably going to be fast. So we'll see. So is survey. On activation functions. Right. So activation functions in deep learning, competency study and benchmarking. Okay, that's the name of the paper. It was released by Shivram Dubey, Pradesh Kumar Singh, and okay, these guys. Cool. Cool. Computer ratio. Oh, IIT. Okay, they're from okay, nice. So before reading the paper, we will read the abstract. We'll just get started. All right. So yeah, neural networks. Let's move on. Wait. Oh, wait. Instead of why we're reading there, we can read here, right? Wait. So neural network has shown tremendous growth in recent years to solve numerous problems. Various types of neural networks have been introduced to deal with different types of problems. Now, the main goal of a neural network is to transform non-linearly separable input data into more linearly separable abstract features using a hierarchy of layers. That's kind of cool sentence, isn't it? The main goal of any neural network is to transform the non-linearly separable data into a more linearly separable abstract features using a hierarchy of layers. I like the sentence. I'm taking it. I have to copy, right? Okay. These layers are the combination of linear and non-linear functions. The most popular and commonly used linearity layers are activation functions such as sigmoid, tanh, ReLU, LU, Swiss and Mish. Okay. In this paper, a comprehensive overview and surveys presented for activation functions in neural network for deep learning. Different classes of activation functions such as logistic sigmoid, tanh based, ReLU based, ELU based, and learning based. Learning based. Okay. Several characters of activation function such as output range, monotonicity. I don't know what that means. Let's go copy this. Let's go here. Let's go like there. Property of function that describe whether it's increasing or decreasing. Okay. So it's okay. The performance comparison also performed among 18 state-of-the-art acquisition function with different networks and different types of data. The insights of acquisition function are presented to benefit the researchers for doing further research and practitioners to select among different choices. The code for the experiment is released at risk. Okay. Hmm. Introduction. In recent years, deep learning has shown tremendous growth. I mean, oh, that's the introduction. We don't do that. All right. So now we skim through the paper. So let's do this and skim through the paper, right? Linear, logistic, and tanh function. Logistic and tanh. Okay. Classification of activation. Characteristic type, properties of activation, different application. Sigma, okay. Uh-huh. Oh, different ways in which we can classify activation functions, huh? Uh-huh. Cool. Give me 1 second. I'll be back. Yeah, sorry about that. Oh, uh, hmm. Logistic sigmoid, Then we uh I rectified activation functions, Well, I think this is going to be very fast speed. Maybe not. I don't know. The adaptive and trainable activation function are the recent trend to adjust the non-linearity based on the data. Uh, Minimal burden is increased in terms of the increased number of parameters. So the complexity of tunable activation function is relatively increased with respect to non-tunable activation function. It is negligible with respect to all parameters. Miscellaneous soft plus softmax polynomial aspect of activation performing comparison analysis. Ooh, activation model dataset. Insights and remote. Mobile model RCFR dataset. So which is the best actually? Mobile net model. What? So this is loss. Lower is better. So which is the worst one? Green. AB relief. Or it could be even be Elliot. Orange. Swish. Okay. Where is relief? Red. Oh, relief is here. There is a Swigglue in this thing. There is Gelu. Gelu is decent. Elu is even better, I guess. So this is a different one. What is the pink one? Oh, well, it's really good here. Hmm. CIFAR 100 data set. Training time. Oh, it takes a lot more time. After Flux is probably Celu is the fastest. What about Relu? They're actually much faster than Relu. This is very slow. Whoa, 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 whoa. What the hell is this? Okay, nice. Experiment decides from German to English natural language translation. Conclusion and recommendation. Yeah, let's read that. The extensive and up-to-date survey of activation functions conducted on this paper, different types of activation function are considered, including okay. Our main focus is given to the recent development in activation function to view the deep learning application of neural networks. The overview of activation functions presented in the paper focuses on the aspects including the detailed coverage of activation function classification and performance. Following are concluding remarks. Most improvement in logistic sigmoid and TANH target to tackle the non-zero mean and zero gradient problem. However, this improvement carry forward the drawback of increased complexity. Hmm. ReLU variants try to tackle three major problems of ReLU, namely underutilization of negative values, limited nonlinearity, and unbounded output. These aggregations perform well for some application. Uh, LReLU and okay, BReLU works with bad. Okay, you are green. However, most of the activation failed to perform better than ReLU. Really. Not that the ReLU, Linear ReLU are the most common choice among researchers due to its simplicity. Moreover, many advocates consider ReLU as default choice for activation function. Yeah, true. The exponential based activation function also focus our better utilization of negative value and to avoid the saturation of impedance which however most of the exponential activations suffer due to non-smooth functions. Okay. The learning-based adaptive activation function tried to find the best parameter to represent non-linearity. Okay. This category of activation has came up in this. However, the main problem with this is to find the better base function in number of random parameters. Some activation function diverge during training if not initialized properly. Okay. Hmm. Sunrise to exercise services, survey covers exercise stuff, performance also different types of data using several exercise functions. Okay. Following in the recommendation, in order to speed up the training, both negative and positive values should be used to ensure the near zero mean. Give me a second. All right. So, the most important aspect in deep learning is to find the network having matching complexity as a data set complexity. Wait. Following on the recommendation curated from the survey. In order to speed up training, both negative and positive values should be used to ensure the near zero mean. What does this mean? Answer concisely short. Data normalization. Using both positive and negative values help maintain distributions, sensing errors and always can improve neural networks predictability. Okay. The most important aspect of deep learning is when the network having matching complexity as the data set complexity. If the complexity of the model is high, then ML or okay, thus the action function should bridge the gap based on the model and data set complexity during training automatically. Okay. The logistic sigma and tanh activation function should be avoided for CNN. As this is pure tanh cannot be used for CNN. I don't know that. However, this type of activation function commonly used in gates in recurrent neural networks. Wow, I did not know that. So tanh is bad for CNNs. And logistic sigmoid. I mean, I can use logistic sigmoid in the very last layer, right? Yeah, it's probably fine. They're talking about the hidden layers, the middle layers. I'm audible, right? Question mark. I can use logistic the very last layer, right? Yeah, it's probably fine. Uh-huh. Despite the ReLU being a popular choice, recent proposed activation functions such as Swish Mission Po are worth trying for different problems. So that's very helpful. Thank you. Okay. So I'm going to note some things. Uh, what is it called? Normalizing and standardizing is very important for most activation functions. Uh, the ReLU mesh and PEW aggregation function have good performance with BGG60 and GoogleNet. Sure. They are better for network having residual connection for image classification. Okay. In general, parametric accuracy functions show better convergence as you can adapt data faster. Okay. Sure. Some accuracy functions lead to increased training time complexity. Our actions such as ReLU, CELU, GELU depict promising trade-off between accuracy and training time. Wow. The exponential accuracy functions generally lead to an increased non-linearity due to the utilization of negative value. Okay. Tangent and CELU accuracy function are found better for language translation. Okay. So I said to use. Okay. Cool, cool, cool. Okay, now let's say the paper. Recently, deep learning has shown tremendous growth to solve the challenging problems such as object detection, semantics. Okay, sure, sure, sure. Well, include weight initialization, loss function, different layers, or fitting in optimization. The accuracy function play a crucial role. It should add non-linear curve. Okay, it should not increase computational complexity extensively. It should not hamper the gradient flow during training. It should retain the distribution of data to facilitate better training. Okay. Several several accuracy functions have been explored in recent years to achieve the above mentioned properties. The survey is dedicated to the development of the okay. This the insights of this of the different accuracy functions present along with the reasoning to benefit deep learning community. The major contribution of the survey includes feature classification. Okay. State of the accuracy function summarizes actually. Okay. Paper also mentions performance comparison. Okay. The evolution of acceleration is explained in section 2. The progress of the okay, cool. No. Okay. Otherwise, a neural network produces output as a linear function of input despite having solveness. However, in practice, data is not linear subproblematic. Sure, sure. This section provides an overview of the values of the classification is present in figure 2 in terms of characters and type. I can screenshot you. Sure, okay, I read that. This section provides an overview of the evaluation of, okay, yeah, sure. Logistic sigmoid, tan H, okay. In order to introduce non-linearity, the logistic sigmoid and tan H have been used in the early days. The firing of neurons was the motivation of using logistic sigmoid and tan H, okay. The logistic sigmoid was very popular in traditional nonlinear function. It is given as, okay. This QSL between 0 and 1, the output is saturated for higher and lower inputs, which leads to vanishing gradient problem. Okay. Used in initial days. Vanishing gradient problem. Still the vanishing scenario. Now the output the now following a zero-centric nature leads to poor convergence. So the second one is tan H function. Similar to while zero center exhibited zero center property. Meta convergence. Retrace this one. Sure. Uh, Good. Causes to -1. 0, comma 1. ReLU. Rectify linear unit based acceleration function. The rectifier has again state of the art performance due to simplicity and poor performance. Simple, high performance ReLU of x equal to max of 0, comma x. It is using AlexNet. Various variants of ReLU have been investigated to tackle its drawbacks, such as non-utilization, limited non-linearity, and unbound output. Okay, cool. That's really cool to know. Those are the default issues with the what is it called, ReLU. Exponential unit. Okay, how many are these there? Okay, that's it. Exponential unit based functions. Faced by logistic sigmoid is with its satisfied for last positive and negative value. Similarly, a major problem with ReLU and AF with underutilization of negative value. You have to cope with these limitations. Okay. Proper utilization of large positive and negative numbers. The exponential the exponential linear unit LU phase the acceleration function utilizes negative values with the help of an exponential function. Okay. I introduced learning rate or adaptive acceleration functions. Learning or adaptive acceleration functions. Okay. Most of the sigmoid are designed manually, which might not be able to exploit the data complexity. The learning-based acceleration function, a recent try, this class of contains learning parameters. The acceleration function of acceleration function contain two and one learnable parameters respectively. Oh wait, Swish. Okay, adaptive piecewise linear. Okay. Recently, several learning-based acceleration functions have been proposed in illustrated in section. Okay, sure. Contains learnable parameters. Uh, can work on very complex problems. More expensive. Okay, so we skip that now. Miscellaneous. In recent many other actions has been introduced. Because softplex probabilistic functions and polynomial functions and kernel functions. Okay. You can notice that dynamic function computation is inefficient because it involves computation of exponential multiple times. Okay. Copy that and I'm going to paste that here. I mean that is true. However, implementation any implementation can be computed using single exponential with the help of sigmoid. Oh, wait, what? In implementation, it can be computed using single exponential with the sigmoid. This limitation in existing extension function have been the driving factor of the recent extension functions. Okay, logistic and sigmoid. Oh, okay. Now we're going to talk in depth about these guys. Okay. The traditional extension functions such as logistic and tangent the trend several items. Okay. In order to tackle the limited output range and zero gradient problems, a scaled hyperbolic tangent is used. Okay. The output range, a parametric sigmoid function. Yes, okay. Choose the final yes, okay. A parametric sigmoid function is proposed to be continuous. Rectified hyperbolic secant activation function is a differentiable symmetric. Okay. Symmetric and bounded. The output, however, it exhibits vanishing gradient problem. Okay. The training of deep network becomes difficult due to the uniform slab of the second segment. Okay. To minimize the segmentation, a scaled sigmoid is used. Okay, 4 times sigmoid minus 2. Sure. The penalized tangent tangent if x is greater than or equal to 0. Otherwise, a small number m. Okay, where a is very small. Okay. Our S sigmoid and P tan H also suffer from vanishing gradient problem. P tan H performs better for natural language processing tasks. Okay. A noisy activation function is defined to overcome vanishing gradient problem due to the added noise of the gradient and noise. The gradient may flow easily even in a saturating regime. The vanishing gradient problem is minimized by Hexpo function, which is similar to Tannage with gradient descent, with a scaled descent, with a scaled gradient. But the sigmoid weighted linear unit. Okay, before all of that, better having reservoir connection with image. Sushi is cool, Gelu is cool, PLU is cool. No, it's not that. I'm going to improve logistic sigmoid. Improved sigmoid, I sigmoid, okay. Propose advancing with the help of a piecewise combination of sigmoid and linear function. Oh, it's just complicated. The linearly scaled hyperbolic tangent. I just want to scale. Okay. Okay, you are just talking about various actors of functions, right? Okay, this actors of function. Okay. Rectified actors of function. This is our super classic ReLU. Hence the range is this. ReLU is the problem computation complexity. Downside is a vanishing and the negative inputs. Part of having vanishing and problems, the ReLU actors function has been very extensively used. Cool. On the non-utilization of negative value of ReLU. Vanishing gradient is the main problem with ReLU. A leaky ReLU. Okay, I know that. It's an extension by adding negative values. The leaky ReLU has been used in many applications promising performance. One major problem associated with leaky ReLU is the finding of the right slope of linear function for negative inputs. One major problem associated with leaky ReLU is the finding of right slope. Uh, the different slope might be suited for different problems of different networks. Okay. Okay, leaky ReLU. I just want to see the performance of a leaky ReLU here. Leaky ReLU uses violet. It's fine. Better than ReLU. Not here though. Arguably. ReLU. Leaky ReLU is very bad here. Not very good. Apparently. Parametric ReLU. Pre-ReLU. Pre-LU. Okay. P-ReLU. P-ReLU. Okay. Uh, I mean, Okay, p-ReLU, parametric ReLU. Consider the swap for what's up, man? Wait, my mouse is. By considering the swap for negative input as a trainable parameter. Oh, okay, that's cool. Uh, p-ReLU is better than ReLU in many cases. So the output range is infinity infinity. Mine's infinity infinity. Okay. A is a trainable parameter. However, if it can lead to overfitting easily. Okay, why? Oh, because it's really good, huh? Hmm. The max out tab, which computes maximum of star or less, is also used as the exhaustion function. Both the ReLU and Likert can be seen as special case of max out. The randomized ReLU. Randomized ReLU, okay. ReLU. And swap of ReLU randomly using the same using training sample from a uniform distribution. Okay, nice. Hmm. p-ReLU Gelu switch mission po. I get a function. Oh, this is for speech recognition. Man. Okay. Okay. Yeah, this is important. Which mission po? Can it better for language translation? Okay. Image classification. It's a mess, but yes, it works. Yeah, I don't think I'll be able to finish the paper today, so yeah. Oh, time went really fast. Randomized value. The value is not able to utilize the potential useful information from negative values. In most output, this feature map gives as the output to activation function is dense near zero. Thus, a small jitter in rectification can have difficulty in training. Concatenated ReLU. Concatenate the ReLU's output over original output and negated output. Okay. The lower kernels and CNN modes form pair with opposite phases. A shifting in the feature map with multiple biases is also performed below. However, it increases the mode complexity as more ReLUs is required. Okay. Parametric and hyperbolic linear units. Okay, sure. The flexible ReLU captures negative values from rectified points. Flexible ReLU captures negative values with a rectified point, which is considered as trainable in shifted ReLU. Random translation ReLU. Utilizing offset. A data-dependent average biased ReLU also invested to tackle negative values. Dynamic ReLU and dual ReLU. For recurrent neural networks. Dual ReLU maximum of this minus maximum of this. What is MB? Two input parameters. Okay. Paired ReLU is used for image super resolution. How the computation complexity of parallels increases as compared to three ReLU. V-shaped ReLU. Okay. The V-ReLU activation function suffers from non-symmetric output. The sign, man, this is just talking about different activation functions. Negative values using okay, displace ReLU. That is power ReLU with some displacement. No, it's not. It is generate shifted ReLU. It displaces rectification point. Okay. Which one shifted ReLU or did I already mark it? Could be because there was so many. I barely remember any of them. Man, this is not fun. Moreover, the range of L value depends upon the values of phi and n. S-shaped ReLU. Increase the non-linearity in ReLU by combining three linear functions. Multi-bin trainable units. Multiple bins to increase the non-linearity. Okay, they're trying to increase non-linearity. Oh, okay, this is a question. Okay. Elastic ReLU. I don't know what it does. Linearized Disha. Natural logarithm ReLU. Rectify linear damage. Non-linearity ReLU. No, I know. Dynamic relation. Piecewise linear unit. Clue. Wish, Mish, and Po. Okay. These are the important guys, I think. Hmm. And the unbound input. ReLU. Bounded ReLU. Okay. Okay. Hmm. I mean, yeah, I think I'm going to end this here because it's already 8, right? Yeah, I would have loved to read a bit more, but I shouldn't. Yeah, so I think that will be for today. Thank you for watching. Yeah, I've been streaming for almost an hour. Huh? I mean, should I like finish this section? How big is this exponential activation function? Yeah, it's small. Exponential activation is tackle the gradient distribution problem of ReLU. Gradient diminishing problem. Exponential linear unit LU. LU is cool, right? Hmm. I should make like a table for different activation functions. I will though. Exponential linear unit LU. Having the output in this where alpha is learnable parameter. Hmm. The ReLU function exhibits all the benefits of ReLU function. Oh, it is a differentiable saturates. I mean, this is important. Differentiable saturates for large negative inputs and reduces bias shift. The negative saturation regime of ReLU adds some more robustness to noise compared to leaky ReLU or parametric ReLU. Okay. ReLU is XFX greater than 0. A learnable parameter into this. Okay. Scale ReLU. SELU. Is that the important one? No, no. Scale ReLU. It is, we scale that thing. ReLU. Parametric ReLU. ReLU with the parameters. Sure. SELU. Continuously differentiable ReLU. Okay. Multiple value. Interesting. The same thing with the slide modification. Soft expansion. Shifted yellow. Shallow. So we have parametric function. Preview. Efficiency is improved. Fast yellow. Okay. Then there's elastic yellow. Some are changes. Parametric deform value. Value okay. Yeah, this paper is not a fun read at all. Linear sigmoid squashing release. Which multiplication of hard sigmoid and linear. Okay. The LU based regression function exploit negative input without compromising non-linearity. Some LU variants also modify the function for position inputs also to make it one. Okay. And I think we'll stop it right there. So thank you for watching. Have a good day. Bye.